Welcome, and thank you for joining us to learn more about the proposed improvements at the intersection of US Highway 2 and Airport Drive near Grand Forks, North Dakota. This presentation was prepared for the North Dakota Department of Transportation and DOT, along with its project partners, the City of Grand Forks and Grand Forks County. I am Thomas Faulkner with Oltec Engineering, and I am the consultant project manager for this project. Our presentation's goal is simple: share where things stand with the project, talk about the work that's already been done, discuss the design alternatives currently under consideration, and most importantly, invite you to share your thoughts and feedback on the proposed improvements. This project is located at the intersection of US 2 and Airport Drive, which has experienced instances of impatient driver behavior, speeding, and a history of crashes. The North Dakota Department of Transportation and its partners have implemented several measures to slow drivers and improve awareness of the intersection. Things like dynamic speed display signs, flashing beacons, dynamic message signs, speed reduction pavement markings, and larger speed limit signs. This intersection has been studied a number of times, and each effort has added valuable insight. Early work included the 2014 Local Road Safety Plan and the US Highway 2 Access Study. A road safety review followed in 2017, and more detailed traffic operations studies were completed in 2019 and 2024. These studies tell us what kind of improvements might help and how different designs could affect travel and reduce crash potential and severity. All that background gives the current project a strong foundation to build upon. Now that we've talked about the information gathered from previous studies, let's look at the factors that define the range of alternatives at this intersection. Every project has its boundaries, and for this one, several key constraints help shape the range of alternatives we can consider. One of the most significant is the Grand Forks International Airport's runway protection zone, which extends towards the project area. These zones are regulated by the Federal Aviation Administration to ensure safe aircraft operations and limit the height or placement of certain infrastructure. In addition, the area includes existing utilities, a water booster station that supports both the Grand Forks Airport and Grand Forks Air Force Base, access roads, business entrances, and the English Coulee watershed drainage ditch, all of which need to be considered during design and construction. Together, these factors establish the physical and operational boundaries for where intersection improvements could realistically fit within the surrounding area. Here you can see the project area. It's been drawn based on a combination of possible design alternatives and the known constraints in the area. The study area also accounts for known constraints such as the runway protection zones, utilities, nearby roads, property access, and environmental factors that could influence the design, such as wetland, cultural sites, and species habitats. As the project moves forward, the information gathered from studies, fieldwork, and your comments will help narrow down which alternative best meets the project's needs. Public feedback is a big part of this process, and one of the ways we've been gathering is through Oltec's Pinpoint app. Pinpoint is an interactive online map where users can drop pins and leave comments about specific locations. Some examples could include a spot where turning feels difficult, or traffic tends to back up, or visibility could be better. The project team has already used Pinpoint during our stakeholder meetings, collecting comments from local partners like the Airport Authority and city staff. Those insights helped us narrow down the initial range of design alternatives and focus on the options that best address the project needs. Now we're opening Pinpoint to the public, so you can add your feedback too. Just scan the QR code on this slide or visit the link to share your thoughts directly on the map. Here's a quick look at where we are in the project schedule. Phase 1 scoping has been completed, covering the initial data collection and early coordination. We're now in Phase 2, which focuses on the environmental document, preliminary design, and continued stakeholder engagement. This phase will run through spring 2026, and it's where we'll evaluate design alternatives and identify a preferred solution. After that, Phase 3 will move into final design, right-of-way, and permitting once the preferred alternative and funding plan is confirmed. Public input is a valuable asset and will remain a key part of every decision as the project advances. Since kicking off the project, the team has made solid progress. We finished surveying work, collected traffic operations data, completed wetland delineations, and held stakeholder meetings, which we'll discuss in a moment. All this information feeds directly into the alternatives being developed and helps us understand the existing conditions, the constraints we'll need to work around, and the opportunities for improvement. I'd like to send out a brief moment of gratitude and recognition to our stakeholder working group who has been heavily engaged in the project development throughout the last year. These entities include the North Dakota Department of Transportation, City of Grand Forks County, Grand Forks East Grand Forks MPO, Grand Forks Airport, Grand Forks Air Force Base, Grand Forks Water Resource District, the North Dakota Highway Patrol, Grand Forks County Sheriff's Department, and the Federal Aviation Administration. We came together for 3 separate stakeholder meetings to brainstorm the alternative development process. They've worked through these alternatives with the information we plan to present today to narrow down to what we believe to be the most feasible and acceptable options for the intersection of US 2 and Airport Drive. We will now take a deep dive into what the data shows on vehicular traffic at this location. Early on, the project team took the strategy of utilizing advanced technology to create a data-driven, comprehensive study for evaluating the intersection of US 2 and Airport Drive. With this in mind, the project team went beyond traditional traffic counts for the study through the utilization of unmanned aerial systems to capture individual driver behavior as vehicles traverse the intersection. Alongside that, we assembled a full stack of traditional sources from earlier studies: the Grand Forks East Grand Forks MPO travel demand model, recent population data to understand growth, the employer household dynamic dataset, survey inputs, and urban SDK, which the MPO uses for visualizing travel time and speed insights. With all that in hand, plus our previous counts, we processed 4 hours of video recorded at 30 frames per second. That level of detail let us extract vehicle classification, lane position, speed, and acceleration at every frame. Every second produced 30 data points per vehicle, which gave us a rich foundation for calibration and analysis. To ensure our single count day was representative, we compared our AM peak hour 7 to 8 and PM peak hour 4 to 5 against prior studies and noticed our totals were consistently lower. To verify representativeness, we partnered with North Dakota State University and used their continuous counter near 55th Street. We pulled the full year for 2023 and 2024 and benchmarked our study data against the daily averages. In the chart, 2024 study counts appear in purple and the 2024 daily average in red, and they are close. For 2023, the average is shown in blue and the prior study day in green, and that day was clearly busier than typical. That does not mean the earlier work was wrong, it reflects day-to-day variability. Our goal was to set volumes that are representative for design and operational decisions, so we anchored our modeling to the continuous counter context rather than a potentially atypical day. Video collected with the unmanned aerial system allowed us to identify and classify high-risk signal entries. We flagged any entry 2 or more seconds after the onset of yellow as high risk, and we binned them by time since yellow, 2 to 3 seconds and 3 to 4 seconds. These events often included drivers increasing speed as they approached the stop bar. We also documented red light entries, including cases 4 to 5 seconds and 6 to 7 seconds after yellow began, plus one heavy vehicle that entered 2 to 3 seconds into red. The counts of high-risk entries were similar between AM and PM overall, but the dominant direction flipped, with more westbound entries in the morning and more eastbound entries in the afternoon. That mirrors the directional flow pattern: more people traveling west in the morning and east in the evening. With the data at hand, we created a micro simulation which is calibrated to more than turn movements. We matched volumes, turning movement counts, corridor travel times, speed profiles, and distributions from the drone footage, acceleration distributions, and vehicle classes. This allows the model to support safety evaluation using surrogate measures that reflect near-miss behavior, such as minimum time to collision and post-encroachment time. The design intent is to remove or minimize mainline queuing and stop conditions at high speeds. As part of our study, we look closely at how well the intersection works, not just overall, but also for drivers coming from every direction. You'll notice that some alternatives experience levels of service D, E, or F on the minor streets for worse approach delays. The reason for minor street level service D, E, or F values is straightforward. Heavy east-west demand starves the northbound and southbound approaches, which produces delays and visible queues. Standard timing tends to favor the main line to keep the corridor moving, but that places a disproportionate burden on the side streets. It's important to know that even when the side streets get a low grade, it doesn't always mean there are huge backups. Because there aren't as many cars on those roads, just 1 or 2 drivers waiting a minute or so can make the average wait time look worse than it feels in real life. Our models show that when a gap opens up on the main highway, the lines on the side streets clear out quickly. After analyzing the traffic data and assessing the physical constraints of the site, Through close collaboration with the stakeholder working group, we have narrowed the project down to two main overarching design approaches, these being either an interchange or a roundabout. Today, we are going to focus on the three alternatives based in these design approaches that have received the most positive responses from the various stakeholders on this project. The first are for the roundabout, with either a single lane or 2x1 roundabout. We'll look at what this means and the difference between the two in a moment. Then for the interchange, we'll be looking at a shifted diamond interchange, which is just a slight variation on a normal diamond interchange. Now, let's take a look at some of the advantages and disadvantages of a roundabout in general. For advantages, we see reduced crash potential, and when crashes do occur, the severity is generally reduced significantly. A roundabout will be able to handle larger traffic volumes than the existing intersection as well as provide more consistent speeds by reducing stops and idle times. It is also a relatively cost-effective improvement to the intersection. As for disadvantages, building a roundabout also requires relatively complex phasing. We will likely see short-term impacts to traffic throughout construction. Next is that while stops will be reduced, traffic will still need to slow down and potentially yield before entering. On specifically the 2x1 alternative, larger trucks may encroach on adjacent lanes while navigating the roundabout. And finally, we will note that the multi-lane roundabouts have a greater crash potential than single-lane roundabouts. However, I would like to reiterate that crash severity is still reduced with both roundabout options. Several national roundabout studies support data showing that intersections converted to roundabouts reduce crashes. Roundabouts provide a significant reduction in injury crashes due to the reduction of conflict points, lower operating speeds, mitigation of high-speed right angle or T-bone and rear-end collisions, and an overall decrease in all types of accidents. Fatal crashes are extremely rare at roundabouts. Single-lane roundabouts tend to perform best due to the simple configuration, least amount of conflict points, and the lack of lane changes. A recent North Dakota Department of Transportation analysis compared crash data before and after roundabouts were installed on the state system. According to the study, overall crash rates decreased by 33%. Total crashes per year dropped by 36%, and fatal plus incapacitating injury crashes fell 59% statewide after installation. Here we have a rendering of what a single-lane roundabout might look like at this site. You can see there would be one lane all the way around the roundabout, along with dedicated right turn lanes off US 2. Here we see what the 2x1 alternative might look like. The big difference here is that 2 lanes would be running east and west along US 2 through the roundabout with only one lane running north and south. Now we will look at examples of roundabouts installed in North Dakota and how they have performed. This is the intersection of North Dakota 23 and North Dakota 73 in western North Dakota, an area that experienced a sharp rise in oil field truck traffic tied to the development in the Bakken. The roundabout here was built to reduce crashes and manage those heavy truck volumes. Despite constant, large vehicle use, it has performed well, reducing high-speed conflicts and keeping traffic moving smoothly. A roundabout study completed by North Dakota Department of Transportation in 2023 shows this intersection has experienced a 33% reduction in crash rate since installation. It's a strong example of how a properly designed roundabout can safely and efficiently handle heavy truck traffic and regional traffic alike. This is the intersection of US 52, US 281, and ND 200 in Carrington, North Dakota. While Carrington is more urban than the US 2 and Airport Drive location, it carries heavy truck traffic tied to agriculture and regional freight. With US 52, US 281, and ND 200 converging at this point, the roundabout was built to manage those high volumes safely and efficiently and has performed well, improving traffic flow and reducing the number and severity of crashes, even with frequent large vehicle movements through the intersection. The roundabout study previously discussed shows this intersection has experienced a 59% reduction in crash rate since installation. Located relatively close to Grand Forks and serving similar traffic types, it demonstrates how a modern roundabout can function effectively in a busy, mixed traffic setting like that proposed at US 2 and Airport Drive. This is the intersection of Main Avenue and 2nd Street South in Fargo, North Dakota. This location represents a 2x1 lane configuration and was built to manage heavy traffic volumes safely and efficiently. The roundabout study previously discussed shows this intersection has experienced an 11% reduction in crash rate since installation. Located relatively close to Grand Forks and serving similar traffic types, It is an example of how a 2x1 roundabout can function effectively in a busy, mixed traffic setting like that proposed at US 2 and Airport Drive. For more information on roundabouts, the North Dakota Department of Transportation has an informational site available that you can access by scanning the QR code, going to the link shown, or searching North Dakota DOT roundabouts online. Here you'll be able to find a variety of information including how to navigate a roundabout, the differences from a signalized intersection, and studies of roundabouts throughout North Dakota. Next, let's look at the advantages and disadvantages of interchanges. Interchange alternatives feature reduced numbers of conflict points, which reduces the crash potential and severity at this location. They also provide improved traffic operations by allowing continuous traffic flow on both US 2 and Airport Drive, resulting in reduced travel times over existing conditions. As for disadvantages, an interchange would have a high cost along with a longer construction outlook. It would have significant impacts to surrounding properties, requiring significant land acquisition. Most interchange variations would encroach on the airport's runway protection zone, and some have the potential to impact the airport's airspace. We'd also likely see impacts to the water booster station in the northeast corner, which would need to be relocated, impacts to overhead utilities, and impacts to the English Coulee watershed drainage ditch to the southeast. Here we have a rendering of what an interchange at this location might look like. One thing to point out here is that this alternative shown would shift Airport Drive and 16th Street about 300 feet to the east to reduce impacts to the airport's runway protection zone and airspace. Across concepts, none of these are capacity constrained in 2050. Intersection delay tells the same story. The single lane and 2x1 roundabouts land in the B range in the PM, while the shifted diamond is A. The differences show up in worst approach delay and queue metrics. The single lane roundabout shows a higher max queue on the westbound approach, but the 95th percentile queue is much shorter, which means those long spikes are rare and clear quickly. The 2x1 can show a longer westbound 95th percentile queue than the single lane, even though the extra lane often helps, and its worst approach delay can read like an F on paper when a few low-volume, gap-seeking vehicles wait 60 seconds to enter. That's a small sample artifact more than a persistent queue problem. In practical terms, typical queues are a handful of vehicles and dissipate. You may wait a bit to find a gap, but you're not seeing sustained lines of vehicles. Operationally, all three are acceptable at the corridor level, so the decision leans more on safety performance, environmental impacts, construction costs, construction timeline, and context, rather than raw capacity. Next, let's look at the expected right-of-way impacts. This is land that would need to be purchased either temporarily or permanently for the construction of each alternative. We currently don't expect any right-of-way purchases to be needed to build the roundabout alternatives, as the roundabout could be constructed almost entirely within the existing roadway footprint. The interchange alternative would require approximately 29 acres of permanent acquisition, as well as 10 acres of temporary acquisition to accommodate construction activities. Here we have the estimated cost to build each alternative. The left column is the estimated cost in today's dollars, and the right column is estimated cost at the time of construction. Due to the lower costs, reduced impacts, and less intensive design and planning process required, the roundabouts could feasibly be built in 4 years. We are currently estimating costs of $8.5 million for the single lane roundabout and $12 million for the 2x1 roundabout. The high costs, greater impacts, and considerably more in-depth engineering and planning required of an interchange means that a realistic timeframe for construction could be up to 10 years or greater. With inflation, we are estimating a total cost of $99.7 million to construct an interchange. As we draw to an end, we'd like to ask that you take a moment to complete the North Dakota Department of Transportation Title VI Public Participation Survey. This short, confidential survey helps ensure that everyone has an equal opportunity to share feedback and participate in the transportation process. You can complete the form by clicking the electronic survey link on the event page. Your participation helps the North Dakota Department of Transportation and our project team understand who we're reaching and how we can continue to improve public involvement across the state. We'd like to invite you to share your thoughts on the project. Please submit your public comments by November 20th, 2025. You can email them to us2airportdrive@alltate.com with public input meeting-pcn2 4422 in the subject line. Written comments can also be mailed to Alteg Operations LLC, attention Thomas Faulkner at 3350 38th Avenue South, Fargo, North Dakota 58104. The QR code and link on the slide will take you directly to the Pinpoint interactive map, where you can view the project area and place comments at specific locations that are important to you. On behalf of the North Dakota Department of Transportation and the project team, thank you for your time, your feedback, and your continued interest in improving the US 2 and Airport Drive intersection. This concludes the public input meeting presentation for the intersection improvement of US 2 and Airport Drive.